All right. How many more times you gonna move that
I
desk?
cannot stand that chair. You can barely sit in it and sit here laying down.
All right. So rational functions are basically complex fractions, and they're going to follow this form. An example would be f of x is equal to 2x plus 4 over 2x plus 2x squared plus 4x plus 4. That would be a rational function. Another rational function would be f of x is equal to 1 over 3x. That's a simple rational function. F of x is equal to x minus 2 over 4x minus 3. That's a rational function. All of these are examples of rational functions. So, what do you do for a rational? Whenever you're given a rational function, what do you do with it? Well, there's many things you can do with it. What do we do? What do we do with rational functions? Well, you can graph them. And usually, these graphs you're going to graph with the calculator. All right, unless you just like punishment. All right, no sneezing. Don't sneeze no more. All right. After you graph them, what else can you do? Well, usually find the domain. That's one of the main questions that's asked of these problems. And you do that by setting denominator equal to what? Why? Because that's the only number that you can't have in the denominator. What else can we do? Well, we can factor and simplify. Factor numerator and denominator to simplify. And we can add, subtract, multiply, and divide rationals. Okay? The first two you can't do with your fractions that you learned back in 5th and 6th grade, but the last two you can. Example, 2 over 4 is equal to 2 times 1 over 2 times 2. And what happens here? Same thing with same thing with 2x plus 4 over 4x plus 2. Well, factor with 2x plus 2 over 2. And what will that leave here? 2x plus 1. And what happens to the 2's? And you're left with x plus 2 over 2x plus 1. So I just took, who's that? Oh, did she leave? She's got it right. This, we just factored and canceled. Here, we factored and canceled. Does this mean the same as this? Yeah, if you plug in x is equal to 1, you're going to get 6 over what? 6, which is 1. You plug in a 1 here, I don't know that's right. Let's see, 2 times 1 is 2, plus 4 is 6. 4 times 1 is 4, plus 2 is 6. All right, so what is 2? What is 1 plus 2? 3. And what is 2 times 1? Plus 1. What's 3 over 3? What's 6 over 6? Still get the same answer. Is this the same as this? This is 0.5. What is this? Same answer. All you're doing is cutting away the fat, cutting away the extras, taking away the extras. So we can graph, we can find the domain, we can factor and simplify or reduce, and we can do this down here. And these basically follow the same rules that you learned back in high school or junior high or wherever. I'm just going to give you, you don't have to write these down. 1/2 plus 3/4. What do we have to have? Common denominator. 2 will go into 4 2 times. 2 times 1 is 2. 4 will go in there 1 time. 1 times 3 is 3. Your answer is 5/4. Now we're going to do the same things that you learned in grammar school. We're going to do those with this. 1 over x plus 2 plus 3 over x minus 4. Well, we got to have a common denominator. Well, these two have nothing in common. So we got to put them together, which would be x plus 2 times x minus 4 plus x minus 2 times x plus 4. And then you x plus 4 is going to be on that. Okay, now how many times will this go into this? X minus 4 times 1 is 1 times x minus 4. X minus 4 will go into this, x plus 2. And then you get x minus 4 plus 3x plus 6 over the common denominator. And that would be 4x plus 2 over the common denominator. And you might can get x plus 1. You ain't going to be able to cancel anything out, so that's your answer. So the same thing that you did back in grammar school, you're doing here to get the common one, denominator. You're doing the same thing that you did back in grammar school with addition and subtraction. Multiplication, you factor and cancel, factor and cancel, factor and cancel. What is division? Multiplying by the what? Reciprocal. So you still factor and cancel, factor and cancel. Now we're going to go through all of this, but that's what we're doing. We're basically evaluating, reducing, and manipulating rational equations or expressions / equations. Just like we did in grammar school with the first fractions that we met, that we came in contact with. That's what we're doing in chapter 4. So let's take a look at what they got. Well, that's the first thing right here. The rational function is that. And here's some examples of rational functions. I've already given you that. And they're talking about the reciprocal value of 1 over x. Well, basically that comes from f of x is equal to x over what? That's where it comes from. What's the reciprocal of 1 over x? Or x over 1? So, graph this one and graph this one. Well, we already know that y is equal to x is like this right here, 45-degree angle, right? So what would 1 over x look like? Well, let's look at it. -2, -1, 0, 1, 2. So that'd be -1/2, -1, 0 does not exist, 1, and 1/2. So let's take a look at that. -2, -1/2. So we'll do this in red. -2, -1/2. -1, -1. 0 does not exist. 1 and 1. And 2 and 1/2. And that's what 1 over x looks like. 1 over x, basically, it converges onto the y-axis and the x-axis. X-axis and y.
That red dot is on the one, so it's the one. No, they go up. You see the red dot is on the one.
Where?
Right, where the
There's
little-
2 right here and
No.
2 right here.
Right below the little arrow button.
Right here? I'm just counting right there.
Yeah, but it still shouldn't be like.
-2, 1, 2, and -1/2. That's that one right there. And -1, -1. That's the point. There are 2 points right there. I just counted. I'm sorry. I didn't mean to confuse you. Basically, the black line bisects these 2 parabolic looking wings, if you want to call it. Now, what about this one? F of x is equal to x squared. What's the reciprocal function of f of x is equal to x squared? Y'all got to think. What is the reciprocal function of f of x is equal to x squared?
Whatever
1 over what?
x squared.
And if you graph those 2,
Priority 1 message coming in on secured channel.
this function, the red function, you know what that looks like. But the blue one doesn't look like that. The blue one looks like the volcano. So you need to maybe remember your parent graphs. You need to add some to it. Go back to your parent graphs that we did a long time ago. I think we got maybe,
Here.
excuse me, we got like 8 of them. Okay, you already got it. 1 over x and 1 over x squared. There's your 2 first rational functions. You sneezed in, I yawned. I'm not supposed to do either one, am I? There they are. So, believe you me, if she has this, then everybody should have it. That means she pays attention like that.
Now you
So,
You said, get out your piece of paper and write these down.
so what if I gave you this? All right, y'all ready? Y'all ready for this? Y'all got to think.
So since out the function, it's going to be the 1 over x squared, and then -4 is outside the function, so it's going to be up or down. So we
Okay, good. You're on the right track. Everybody should be doing what she's doing. Everybody should be saying, okay, this is what shift. What is this shift right here?
to the left,
To the left 2. What is this shift?
down 4.
Down 4. Now, what's the parent graph?
Left,
The parent graph? Good gosh, how did I do that? Oh, that's highlighted. Sorry. Hold on. There we go. The parent graph for this one is the volcano, right? So that means we got to take that volcano and we got to move it 2 to the left, and what? 4 down. So instead of the origin being here, 1, 2, 1, 2, 3, 4. Now the new origin is right there, and we draw our, and I'll draw it on grid. Our new one looks like this. The same function, only it has a new what? A new vertex. And the new vertex is -2 and what? Now you can call it the origin or you can call it the vertex. It doesn't matter. The whole point is you got to have one point that you move to the left or right and up and down. And that point with this function the point that you have to move is right. Sorry. Ooh. That point for this base function is that point right there. And what we do is we move it 2 places to the left and 4 places down. Because of these 2. So, does the same thing apply that you learned back in Unit 1? Yes. Everything applies. How about that one? So that means you're going to move it to the left too?
No, but it's not. No, it has to be
Yes,
so
it's with this X right here.
so there's no
There. How's that? Is that okay? So -2 and what? +6 is our new vertex. Well, you've got to think. What is our parent graph? The parent graph for this function is this, right?
I thought the X one was just,
If the number is attached to the X, that's the horizontal shift.
no, but I thought, on that one, never mind, just kidding. No, never mind, just kidding.
All right. So now I'm going to move this point right here. I'm going to move it 2 to the left. I'm going to move it 6 up. And I'm going to draw a new set of. There's my X and Y axes. And you don't have to do this every time, but when you get used to it, you'll know what to do. And now just draw your new graph. There.
So wherever that point is, when you draw the line, you don't actually touch that point. You just go along.
Yeah, these are converging functions. These functions, they go toward a point, but they never what? They never reach it. They converge onto it.
Oh, well, when you have to graph this on your computer, how are we not gonna like murder trying to do that?
They're just going to give you A, B, C, and D, and you pick it. Now, the only thing that I really care about on these type problems is that you are able to pick out the graph using the horizontal and the what? Vertical shift. So you're talking about 2 or 3 problems on the test, and we'll look at. Let's go ahead and look at the homework for this section, so you can see what kind of problems I'm talking about.
Did we send you one?
No, I'm gonna pull them up on my homework. I'm gonna pull them up here. That way, I can pick what I want. There you go. Well, no, they don't give you the. They're giving you the domain. I don't want that. I want to give you the function. Okay, now they're getting into it right here. Well, I thought they would. Okay, they're just asking you for the. Okay, there we go. Here's a test question right here. Go ahead and write it down. I'll blow it up a little bit. No mustard and mayonnaise. I guess I'll just have to eat it plain.
Well, I feel like one of those kids that are just like,
Where are they from? Where'd you get the biscuit from?
got a biscuit.
I bought pizza, and y'all were too early to get pizza, so don't even go there. I bought y'all biscuits, so be quiet. I gotta buy y'all biscuits again. Oh, that's next week, right? Right, birthday? Well, it ain't on Monday or Tuesday, is it? Because we don't come to class. When's your birthday?
No, that's right, we don't come to school on Monday.
So we'll have to celebrate Wednesday. Okay, biscuits Wednesday. Anyway, I got one of my classes, the 11 o'clock on Tuesday and Thursday. They're a fun class. I bought them. I said, we only got one section to cover today, so I can either let y'all go early or get y'all pizza. And they wanted pizza. So I said, okay, I'm going to get y'all pizza. Well, one of the girls walked in and said, hey, pizza. Excuse me? I'm buying pizza for the class and you turn around and snarl your nose up at pizza?
Ain't how to eat it.
That's what I told her. I said, when it gets here, you just go get you some crackers. What has gotten wrong with our society? A teacher buys you pizza and you're going to snarl your nose at it. I just don't understand. Huh? Yeah. You don't ever look a gift horse what? Good job. No. You don't look a gift horse in the mouth. Some of y'all are going, what's he talking about? I'm going to give y'all a bonus. You know what? I'm going to make up some new bonus questions. And they are going to be similes. They're going to be similes. Yep, because your parents. You tell Paul that he's going to help you fail because he's going to teach you your similes. And one of them is you never look a gift horse what? In the mouth. What does that mean? No, you don't have to answer. See who else knows about it. Anybody? I'm determined. I'm going to do this. I'm going to put extra questions on the test, and you have to look them up. And especially with Google, y'all got the world at your fingertips. And whenever I go to a conference and one of these academic gods use a word that I don't know, what do you think I do? I just sit there and go, I don't know what that means. I pull out my phone and I Google it and I find out and then I write it down. If I have to memorize it, I have to write it down. So don't look a gift horse in the mouth. Never look a gift horse in the mouth. So Hubert didn't just make that up. What does it mean? It says, do not be unappreciative. That's what it means. For a gift or a handout. Y'all know another one? We'll look up another one for you. Y'all suck.
Oh, I get it.
Huh?
I get it now. I'm sitting here the entire time like, I still like gift horse. Someone gives you a horse and you, okay, I got it. Yeah, there.
Don't look at his mouth and say, I don't know, this horse is kind of old.
Okay, now I know it. I ace your toes.
You're going to ace it. I'm going to put that on there. That one is going to be on there. Quack, water, I need to go to the bathroom, and don't be unappreciative. And somebody will get it wrong. Nobody has another one that you always wondered about? Y'all suck. Don't throw out the baby with the Bathwater. What does that mean?
Kind of vague on it.
Your parents
I've heard it
suck,
before.
okay? You should have been taught this, huh?
I've heard it before, but I'm kind of vague on it.
It's kind of like don't cut off your nose to spite your face. What does that mean?
And that one I feel
Here's
like.
one thing wrong.
Yeah, don't make two things wrong, or two wrongs don't make a right, or don't give away this because you don't like this, or don't sell this and sell this. It's kind of like, you ever seen the movie Tin Cup? Oh, it's a great movie. You need to get it. Oh, God, I watch it all the time. I have it saved on my direct, and I watch it whenever I get bored. I watch it. Anyway, he's a golfer, and he runs a driving range, and he owes money, and he sells his golf clubs. All right, what's wrong with that scenario? He's a driving range pro. He owns a driving range. He owes money, so he sells his golf clubs.
Where did the golf clubs come in and drop them?
Driving range. That's where you hit golf balls and you teach people how to hit golf balls. Why is it wrong for him to sell his golf clubs? It's his bread and butter. That's throw out the baby with the bathwater. He's selling his clubs, but that's what he makes his what? His money with. So that means idiom. That's what I was looking for the other day. Used to digest the the avoidable error in which something good is eliminated when trying to get rid of something bad. He's trying to get rid of his debt, but he's selling his golf clubs, which he makes his money by. That's one part of the movie that I never could figure out. And I would sit there and say, why is he selling his golf clubs? Sell your car, sell your tires that you hadn't put on your car, but don't sell the only thing that you know how to do. That'd be like me selling my cows. That's one of the things I know how to do, is raise cattle. I'll give you one more.
There are a bunch of them.
Oh yeah. Cut off your nose. No.
There's a song. Can we please watch the song?
No, because it's probably a new country song and I don't want to, it'll just piss me off. Cutting off your nose to spite your face.
There's something,
No, the last one was throw out the baby with the bathwater.
no, we don't do it.
This is self-destructive, overreaction to a problem. Don't cut off your nose to spite your face. Or against pursuing the revenge in a way that would damage oneself. Kind of like in the movie Basic
A
Instinct.
lot of movies.
I am a movie nut. I can watch movies all day long. You just don't give me a comedy because comedies now are stupid. They put 2 or 3 guys together,
You know
get
they
drunk,
come
and
out
can't
with
remember
Dumb and Dumber?
anything, and that's supposed to be funny.
You know they're coming out with Dumb and Dumber again? I cannot wait to see
But,
that.
I have to say, Step Brothers is one of my favorite movies.
I will not
think
watch
it's
that
hilarious.
guy's movies because he creeps me out. When I see that guy on TV, I turn it. He creeps me out. The guy that plays all those funny movies, he creeps me out. When I see him on TV, I turn it. He creeps me out. You ever have somebody creep you out? Don't say Hubert, all right, please. That will hurt my feelings. But do you ever met anybody that you don't want to be around because they creep you out? Okay, that's it. I've never met Will Ferrell. He's probably a nice guy. But when I see him on TV, I turn it. He creeps me out. Tobey Maguire that played Spider-Man, he creeps me out.
What? He's the best Spider-Man.
No, I like the last one.
You guy?
Yeah, I like him.
Hey, go.
Yeah, I like him. I liked him in Social Network. I liked him in that movie. I just like him. I like the way he acts. I don't like Tobey Maguire. Okay.
The thing is, you can only remake Spider-Man so many times by telling exactly the same
Nah,
freaking story.
I don't. But see, I'm one that watched Tin Cup. I've watched Tin Cup 15,000 times. I can watch some movies over and over. Some movies I
No.
wouldn't give you 2 cents to
They
watch
came
over.
out with Spider-Man, then another Spider-Man with different characters, and then another Spider-Man with different characters, and then another Spider-Man with the remake, like the Spider-Man Black or whatever the last one was. like this, you're telling me exactly next door.
Okay, I got a caveman question. Who's hotter, the redhead or the blonde?
Redhead.
Right in.
That's a caveman question. You're not supposed to answer that.
I can give my input.
This is impossible.
Right in.
I don't think, huh? I can't, oh God, they're both hot.
No,
Right in.
And I'm not a blonde or a redhead person, but they're both hot.
no, some people can only do it.
I'm gonna be caveman here for a few minutes. I'm never a caveman,
No, but only
Through
some
the
people
comments,
will
Mary
read.
Jo.
but what's her name is even hotter in Gangster Squad. She is smoking in Gangster Squad.
Through the comments, Mary Jane's hotter than her.
Yeah. Okay, caveman, go away, go away. All right. My favorite actress of all time is Sandra Bullock. Sorry.
Sandra Bullock.
She is so hot. And the reason she's so hot is she's so clumsy in some of her movies. She's just so clumsy and she's just hot. All right. Okay, caveman, go away. What we do? Well, plus 0. Can't stand when I blow stuff up, y'all. Okay.
Negative 4 is inside the function, so it would be the right 4.
Right forward. Okay, so let's nullify, or whatever the word is. Let's get rid of anything that doesn't go right to the forward. Well, everything goes right to the forward, so we can't do that. What about these two guys? All right, or these two guys? Which one is not a squared inverse function? Well, what does the squared inverse function look like? Volcano, right? Which one doesn't look like a volcano? A and D. Now, which one looks like a volcano, and why doesn't the other one look like a volcano? Well, this one would have a negative out front, out here, right there. And that would be that one. So that one's not it. So your answer is C. Now, the whole point of me showing you this problem is to show you that with what you learned in Unit 1 and Unit 2, you can apply in this section and not even have to work very hard. You just have to look at it, put that 0 out there so you don't screw it up, because somebody's going to screw this up even though it's real easy.
So that's what the negative looks like on B. It's only down.
Volcano going down, the drain.
Well, it's kind of hard to tell like when they're upside down, but pretty much like you're on the lower half of the graph.
Just think of it as those rods trying to water wheel. Okay? Y'all have no idea what I'm talking about.
You just make the most odd analogies in my brain.
You need to do something where you can relate to.
I think you were
Yeah, like.
Oh, like uncreative country music and stupid movies. Yeah.
Okay, I will have to say, have you heard the new country song?
I will not listen to country radio stations.
Okay.
I don't listen to them.
The
Is
one
it
about
is it the
how
one
to-
about partying in the Walmart parking lot?
What?
Is it the one about partying in the Walmart parking lot, or is it the one that talks about
Oh, come on.
my big
Lord.
green tractor, or the one that says chew tobacco spit, or the one that says chicken dinner by the river, or catfish dinner by the river? And you want me to listen to country music on those stations that play that? No. I got my XM radio in my truck because the last one, when I heard chew tobacco spit, I went to Walmart and bought me an XM radio to where I could listen to George Strait and Alan Jackson and Brad Paisley and everything from Brad Paisley before. That's what I listened to. Anything after Brad Paisley is junk.
Okay, you know who Bruce Springsteen is, right?
Yeah.
That's this girl, you know, I downloaded a song on my phone. She's like, who's that? I was like, Bruce Springsteen. She's like, but who is that?
Oh, bull crap. She's heard of Bruce Springsteen.
It's like, really?
That's like saying you never heard of
Who's that?
Johnny Cash.
I could hurt somebody that didn't know Johnny Cash.
What?
Might have hurt somebody that don't know.
Yeah, I mean, Johnny Cash had his, I think Johnny Cash was the only person that besides Elvis, that had his own music. just like George Burns and Frank Sinatra had their own music. I think Johnny Cash had his own music. It wasn't country, it wasn't southern, it wasn't this, it wasn't rock, it was Johnny Cash. He did his own thing. All right, I was going to pull up for you. They call it divining rods. Is that right? Oh, y'all don't know. Dang old divining rod. Dang old water, finding water. Y'all ain't never seen those before?
I've seen it.
No.
What does it do?
Finds water. The copper and the metal in the rods. And when you get over a high water source, like a well or an underground river or something like that, they'll cross. Hold on.
Just walk and they go forward. and
Hold on. Just hold on. I ain't believing this.
Nobody knows
I actually played a song. that has to show us how this works.
No, I'm doing it. Oh, that's some real stupid music. Okay, are you gonna like do something or what?
I'm going to show you how to make a simple divining rod from
Okay.
a wire hanger. Cut about right here,
Now, you think, first of all, I'm gonna stop this.
right here.
You think that this is funny or you think it's make-believe? I know 2 civil engineers that have these. They bought them and they will use them. They got them in their car. 2 civil engineers. One is a civil engineer for an engineering firm in Greenville. The other one is got a civil engineer in Anderson. And they do like Walmart parking lots and they do all kinds of civil engineering work. Both of them have divining rods in their car in a little case. Both of them, they bought them, and they use them to find any kind of underwater river or any kind of underwater anything under the ground. Sorry. So it's not a joke. They actually use them.
My grandpa did one.
Will you be quiet? What is this? Oh, he put it on.
And we're going to cut that right in two. Right in the middle. Square shape like that.
Oop. Oop. The speaker Nazi took the knob off the speaker.
Hold them gently in your hand. They need to be able to swivel easily like that. And what these will do, they will turn in line either like this or like this when they are under or over electrical, PVC, or
Finds that
cast
too.
iron pipe,
Magnetic field.
drains, etc. I'll show you now. There's an electrical line above us. And I'm going to walk under that. Watch this. When I do that. See how they turned into each other? Walk away. Turn it.
No, this is also, look at the way he's holding them. He can't turn them. He's holding them like that. It works because in surveying,
Here's how you can pick up water lines in a yard, even PVC or cast iron. So we're going to show you up in the yard how walking across the yard you can find out where the supply line is.
okay, I want to go back here a second. Darn it. All right, see his fingers right there? His fingertips are back in his hand. The rod is right here. There's no way for him to be able to turn them. I mean, there's no way because the fingertips, you can't see it. The wire is right here. The fingertips are behind the wire. There's no way for him to do that.
My neighbors are gonna think I'm on crack.
No, they won't. They'll probably say, did you find anything?
No, they're probably-
Because most people know what divining rods are.
No, but they're gonna be like, do you want me to take you back inside?
how you can find a sewer drain. You can see the clean out, and see if we can find the location of the sewer drain under the pavement, and it will be at least 5 feet underground here.
So how does he do that?
So what I've done is I'll find one spot, place a brick,
I guarantee you he's probably an
down a
engineer.
little bit. Find another spot, place a brick.
One reason I say that is because
And as
he
you
ain't
can
got
see in the
anything to
end,
do.
that they are in a straight
And
line.
two, he's wearing,
That's where the
you know,
sewer
tennis
line is.
shoes with regular work clothes. That's usually an engineer. Anyway, I thought I'd show you that. Let me show you something else. If you think that's bogus, let me show you something else about magnetic fields. In surveying, now we use metal detectors. But what did we use in land surveying before metal detectors to find a pin? Well, you had to use something because you couldn't just juke around in the ground with a bush axe. That's what we used to do. I don't even know. I wish I had my dad's because it'd be an antique. It'd be worth a lot of money now. Magnetic. I bet it's not on here. Land surveying. Magnetic needle. Metal detector. Metacello? I don't know what that is. Probably not going to find it there. Control C. Go to Google. Where's Google? There it is. Control V. And images. Anyway, it was a little box, and it was like this. It looked like, you remember the old brownie cameras, you know, that you looked in like this and took a picture. Well, that's what it looked like, and it had a long strap on it, and you held it like this, and it had a needle like that, and it was like a compass, and you would go along the area wherever there was you thought there was a property corner, and whenever it was over that metal object, it would what? The needle would react. I wish I could find one, but I wish I had my dad's. There's no telling how much money that thing would be worth now, because it was like 500 years old. But anyway, I doubt there's even a picture of it. I don't even know what my dad did with it. But anyway. But the divining rods, I'm sorry, I'm chasing rabbits. But the divining rods, how does that, they look like divining rods right here. Looks like divining rods going down, divining rods going up. That's what they look like. Or a volcano going up, or a volcano going down, whichever one you want to do. All right, let's try nerding. Try that one. What's that one look like? Shouldn't take you but a few minutes. Which one is it? Well, it's x to the first power, but it's a rational. So which one does it look like? Does it look like a volcano, or does it look like that? It looks like this one. So the volcanoes, you can take them out. And it's got a horizontal shift of what? 2 to the right, right? So that one's 2 to the right, so it's okay. This one's 2 to the right. So which one is it? Well, what's the parent graph of 1 over x? That's 1 over x right there, right? What is negative 1 over x? Well, that would be the opposite, wouldn't it? So that would be something like this. So which one is it? A. So make sure you can do that. Make sure you're able to pick out which one's which. Y'all feel good about that? Yes, Hubert. Okay. I guess we'll talk about stupid country songs and maybe y'all will talk to me. No? Okay. Just talk to myself. All right, let's talk about the domain and range of this function. What's the domain and range of this function? Well, graph it. But if you wanted to find the domain of this function, you set the denominator equal to what? 0, because you can't have 0 in the denominator. So x plus 5, quantity squared, is equal to 0. Take the square root of both sides. X plus 5 is equal to 0. X is equal to negative 5. So what does x is equal to negative 5 mean? If I plug in negative 5 into the function, what will that do to the denominator? It'll produce 0 and the function will blow up, or it will be undefined. So we can use all real numbers except for x cannot equal what? Negative 5. There's your domain. So to obtain the graph, shift, blah, blah, blah. I thought they asked for the domain and range. Okay, there it is. Okay, what is this function doing? Left 5, down 1. So you're going to hit left 5 and shift 1 unit what? Down. Now, what is this? Circle this right here. I want you to, well, just sketch the whole function. Sketch the whole thing. When you sketch it, what do you come up with? Well, you're going to have the parent graph for this guy is the volcano, right? But what's wrong with this volcano? It's going which way? Dividing rods. So our dividing rods look like that. They're going down. So you know this one is going to go down. It is symmetric around the what axis? What is it symmetric around? The y-axis. In other words, the y-axis is the mirror. So reflects across the what? Y-axis. And is 1 unit down. And we feel good about ourselves.
No, we didn't reflect over the x-axis. It was going upward.
Oh, I'm sorry. I didn't draw it right. We got to go left 5. So that would be, let me do it in red. 1, 2, 3, 4, 5, and then down what? 1. So our new is right there, so I'm just going to take this guy right here and I'm just going to draw this like this, and here is our new one. So it's not symmetric around the y-axis, it's symmetric around y is equal to what? 1, 2, 3, 4, 5. Y is equal to 5. That's the answer. I don't know if they is symmetric or it's still symmetric around the y-axis, is it not? I mean, it looks like to me it is. Let's see what I did wrong. What's the answer? Okay, sir. I don't understand how it's symmetric around the x-axis. No, that's convergence. Oh, wait a minute. Wait a minute. Hold on. I think I see what you're talking about. Hold on. Let me move this. To obtain the graph of f of shift the graph. Oh, that's what you're saying, isn't it? Shift this graph. Okay. We took that graph we took the parent graph, which was, I was thinking of something else. We took the parent graph, which is right here, and what did we do to the parent graph to get this graph? We flipped it around the what? The x-axis. What is this function? This function, the one right here, the red function, is symmetric around the what? Is symmetric upon the y-axis. But what they're asking us is, what did I do to the parent graph to get this graph? That's what they're asking. My bad. Is that all they asked? Okay. So this right here, you need to make a note. Parent to current graph. So that's what they're asking for there. And then that would be -5 and -1. Is it this one? That's not. I thought they were going to ask the domain and range. Okay. So what's the domain? Negative infinity to what? Negative infinity to -5, and then from -5 to what? To positive infinity. And you would not use brackets on -5 because you cannot touch -5. Because if you touch -5, it will mess up the function. So we're going to type in parentheses, negative infinity, comma, to -5, parenthesis, and they're probably going to want you to put a union or an intersection. That'd be a union. Do they have a union? Yeah, right here. And then from -5 to infinity. -f to infinity. You reckon that'd work? Golly, y'all just are. Let's talk about something else.
On Facebook.
Okay, well, I'm glad you're doing something instructive or constructive. All right, what's the range from negative infinity to what? Or looks like, yeah, -1, thank you. Negative infinity, comma, -1. So make sure you can do this problem. If you can do this problem, you can pretty much do whatever I give you as far as graphing, domain, range, anything like that. Capiche? Point 2. is probably going to be solving complex rational stuff. Okay, they just want us to. Okay, this is where we get into the factoring. What is an asymptote? Write that down. An asymptote is something that the function converges onto, but never what? Never touches. It's the axis that a function will converge to, but never touches. Now, first of all, you need to understand what a vertical asymptote is. And I call it tote, T-O-P-E, but it's tote, like toting water. Okay, y'all probably don't know what toting means. But anyway, carrying water, toting water. If I have a function, and that function looks like this. Oops, yeah. This number right here, that right there is your vertical asymptote. Alright, this function converges onto the vertical asymptote, but it never what? It never touches it. What about the horizontal asymptote? Is y is equal to 0. Here's your horizontal asymptote. Now sometimes I get them confused and I say this is the vertical and this is the horizontal, but I think I got it right. Horizontal asymptote. And sometimes I don't know how to say it. Now how do you find the vertical asymptote? Well, the vertical asymptote is found by setting the denominator equal to what? 0. Setting the denominator equal to 0. Is it A-P, M-P, T-O-T-E? Asymptote. Okay. So, to find your vertical asymptote, you set denominator equal to 0. No hiccup. To find your horizontal asymptote, you have some rules that you need to follow. And the rules should be on the next page of the, and they require you to look at the degree of the numerator and the denominator. And there's 3 rules. Don't worry about it. You'll be all right. Hold on. Wait a minute. I've got to find the rules so everybody can copy those down. I don't worry about everybody. I don't worry about you.
You see now on Facebook?
Whatever. Somebody's been drinking heavy this morning. All right, where are the rules? They're supposed to be, dang gum, girl. I didn't know cheerleading was that much pressure. You need to slow down on the vodka. All right, there they are. Other asymptotes, you need to write those down right here, and then we'll go back to the page where I had to. It's on page 279, so you need to write page 279 down. So, if the numerator has a lesser degree than the denominator, what does that mean? Well, that means your dadgum exponent. So, the first one right here, and these are very important, so you need to write them down. So, f of x is equal to x over x squared minus 2. What's the degree of the numerator? the degree of the numerator is 1. Because it's x to the first. What's the degree of the denominator? 2. So, if the numerator has a lesser degree than the denominator, then their horizontal asymptote is what? Is 0. So in this case, your horizontal asymptote is equal to 0. Whenever the numerator has a lesser degree than the denominator. You're going to love number 3. 2. If the numerator and the denominator have the same, f of x is equal to 3x over 4x. Well, the degree of the first one is what? 1. The degree of the second one is 1. So we've got 2 that are the same. Well, what if you have 2 that are the same? Well, let's read it and see what it says.
You have a work email.
If the numerator and the denominator have the same degree, and the function is of the form a to the n, meaning a coefficient raised to the n, x to the n, and another coefficient raised to the n, then what is your final answer? The coefficients. So, basically, these do what? They cancel, and what is your final answer? Your final answer is x is equal to, your horizontal asymptote is equal to 3/4.
Do we need to write down the whole
No, you just need to write down right here. If numerator and denominator have the same degree. And then do this example. Then the horizontal asymptote is the coefficient A over the coefficient B. And coefficient is a 25-cent word for the number in front of the variable. Right? Now here's the one y'all love. Why do y'all love C? Well, if the degree of the numerator is higher than the degree of the denominator, then what do we use? Here's 2, and here's 1. So the degree of the denominator is less than the degree of the numerator. What do we use? Long division. And then you either find out that the horizontal asymptote is equal to a number, or you're going to find out if it's equal to some form of x, which is not a horizontal asymptote, but a what? Oblique asymptote. So there's your 3 examples of how to find the horizontal asymptote. So you need to be able to find the vertical asymptote and the horizontal asymptote. So let's look at a couple of examples. I'll let you finish writing that down. Huh?
Move on.
Horizontal asymptote. Okay. So, let's look at an example or two. All right, let's look at this one. I don't know what it looks like, but we'll look at it. All right, 2x plus 1 over x minus 3. Whatever. So, f of x is equal to 2x plus 1 over x minus 3. So our vertical asymptote is equal to x minus 3 is equal to what? And x is equal to 3. So our vertical asymptote is x is equal to 3. So that means we've got a graph and x equal to 3. There's a vertical asymptote. What do you notice about these two guys? They're the same. So we've got 2x plus 1 over 1x minus 3. Now, if you cancel these two out, you basically end up with getting 1/3. Or negative 1/3, and that is our y-intercept. Yeah, y-intercept. Yeah, 1/3. Yeah, plug in 0, that's our y-intercept. So our y-intercept, you finished. Y-intercept is, plug in 0 for x, we get negative 1/3. So that's one of the things we want. And then your horizontal asymptote, or to plug in, we've already found the x-intercept, which is 3. So that's going to be right there. So we got a y-intercept of negative 1/3 right there. And then we have a horizontal asymptote of 2 over 1, which is what? 2. And what kind of graph is this? Well, you got x over x. So you might have to graph that one in your calculator because it's going to be x over x. Where's the horizontal asymptote? I don't see it. Is that not? Okay, the horizontal asymptote right here. Y is equal to 2.
Step 5, it says the graph does not intersect its horizontal asymptote.
Yeah, since f of x is equal to 2, has no solution. So graph it, and you'll see what I'm talking about. So get your handy dandy calculator out, and it's right here, but it's going to be looking something like this. Like that, like that. So get your handy dandy calculator out. that's going to give me somebody give it to me. What is it?
2x minus
2x, so I'm going to put parentheses, 2x minus 1, close parentheses, divided by, what's the bottom?
1, x minus 3.
X minus 3, close parentheses, and hit graph, and there's the function. Now, it's not going to show you the x and y intercept. I meant the vertical and horizontal intercept. Oh, gosh. The vertical and horizontal asymptotes. It will give you an indication of the vertical asymptote, which is right here. There's your vertical asymptote right there, which is, I think we came up with what? I can't remember now. 3 or 5. I can't remember. We just did the problem. Oh well. And your horizontal asymptote is 2. Right there. So that's what it should look like. Now, what I don't understand what all the other stuff they said, but go back to the problem, pull it back up. There it is. There's mine right there. And that's what I want you to be able to do. I want you to be able to sketch the graph by using the vertical and horizontal asymptotes. Find the domain, find the range. So let me, hold on. What's the domain of this function? Well, the domain is from negative infinity to what? Where's the vertical asymptote? X is equal to 3. So negative infinity to 3, does it touch 3? No. And then from 3 to what? Infinity, because this is an arrowhead. And this is an arrowhead. All right? What is our range? From negative infinity to what? What did I find? 2. And then from 2 to what? Positive infinity because of that. Question, right, complaint.
Okay. The y-intercept negative 1/3. Shouldn't it be like in the middle of both of those? Y-intercept?
It's right here.
Yeah, but I'm saying shouldn't it be in the middle of like both of them?
No, the y-intercept is right here. This one don't cross the y-intercept because it doesn't cross this guy right here.
So the y-intercept is only in like.
The only y-intercept is this one because this is the only line that crosses the y-axis. This one never touches the y-axis because it never crosses this guy.
So shouldn't that one have an x-intercept in?
No. Doesn't cross this one's in, this one, think of this as a fence. This one doesn't cross the x or y-axis because it can't get across this fence.
So if the other one didn't cross the line, it wouldn't have a y.
It wouldn't have a y-intercept. All right, how we feel? Feel good? All right, well, I'm going to take the roll and I'm going to let y'all finish out, and then we'll go over questions when y'all come back. When? Wednesday?